Hello everyone, this is Ketisha. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 2 Higher Tier from 2023. Question number 4 is on the topic of chemical analysis. Some types of water contain dissolved substances. A student investigated the mass of dissolved solids in distilled water and in seawater. Figure 1 shows the apparatus. You have an evaporating basin with the sample of water supported by a tripod and heat usually from a Bunsen burner. This is the method used. Weigh an evaporating basin. Add 20 centimeter cube of distilled water to the evaporating basin. Weigh the evaporating basin and the water sample. Heat the water sample for 2 minutes. Weigh the evaporating basin and contents. Repeat steps 1 to 5 2 more times. So that for each water they're doing it 3 times, and then finally repeat steps 1 to 6 with seawater. So they're evaporating the water, heating it for 2 minutes, and then measuring the contents. The method used by the student did not give valid results. Describe one improvement the student could make to obtain valid results. Now, if you are trying to find out if there's any dissolved solids in distilled water or in seawater, you don't need the water, so you can't time it for 2 minutes. It's better to actually heat it till all the water is evaporated. Even then, if there's still something left, let's say some solid is left, it might be wet, so you need to heat it several times and keep measuring the mass till you actually get there's no change in mass. So how do you write this answer? Heat the evaporating basin and contents until a constant mass is observed. So you can't time it in this practical. So a different student used a method which gave valid results. Table 2 shows the results. So you have type of water, test 1, 2 and 3, and then the mean finally. Distilled water, all of them are 0. The seawater, they have given test 1 and test 3 and the mean value. Calculate the value x for the mass of dissolved water. How do you do that? Now, well, the mean is calculated by adding these 3 values. 0.30 plus x plus 0.26, divide that by 3 will give you 0.39. So how do you find the value of this? So let's add these 2 values up. That is 0.3 plus 0.26. That gives us 0.56 plus x equals. And I want to get rid of this 3, so I'm going to move it to the other side and multiply this by 3. So 0.29 times 3. So 0.29 times 3 is 0.87. And to get rid of this 0.56, I'm going to move it to the other side and subtract the 0.56. That should give me 0.31. 0.31. The student concludes that distilled water is pure. Describe a test to confirm that distilled water is pure. Now, pure substances, whether it's water or anything, if it's pure, then it should have a very specific boiling point or a melting point if it's a solid. So here you can test the water by heating the distilled water, and if it starts evaporating at 100 degrees Celsius, then it's pure. So the test is determine the boiling point. Pure water boils at 100 degrees Celsius. That would be the result. Or you could say determine the freezing point, and pure water freezes at 0 degrees. So this is your test. And that's your result. Next question. Tap water is potable. A stage in the production of potable water is sterilizing. Now, before we move on, what is potable? Potable water is water that is safe to drink. Right? A gas is used to sterilize water. The equation for the reaction is Cl2 is chlorine gas plus the water gives HOCl hypochlorite plus HCl. Question 4.4. What is meant by the symbol, this double-headed arrow, which the top bit is pointing in to the right and the bottom bit is pointing to the left? It is called a reversible reaction equation. We say it's just a reversible reaction. In normal chemical reactions, we just use a single arrow, which basically means from reactants forming products. Because this is double-headed, which looks like this, so that means it can happen in both directions. The reaction is at equilibrium. The reaction is exothermic. So what does equilibrium mean? Equilibrium is when the rate of forward reaction is equal to the rate of backward reaction. So if this reaction is exothermic, what happens to the equilibrium position when the temperature is increased? Now, if it's exothermic, it gives out heat. Now, when they say the reaction is exothermic, they are talking about the forward reaction, because we're talking about chlorine gas reacting with water. So that's the forward reaction. What happens to the equilibrium position when the temperature is increased? Now, if you increase the temperature, the chemical reaction will try and do the opposite. It will try and reduce the temperature, right? So remember, the arrow was basically like this, right? So this is your right hand side, this is your left side. So going forward is exothermic and going back is endothermic. So what happens to the equilibrium position when the temperature is increased? It'll try and shift to the left hand side. So when you increase the temperature and the temperature is increased, it will favor the endothermic reaction, which is towards the left hand side. So the answer is number 1. Question 4.6. Describe a test to identify the gas used to sterilize water. The gas that is used to sterilize water here is chlorine gas, Cl2 gas. What is the test for chlorine gas? You can test chlorine gas with a damp litmus paper. And what happens when you introduce a damp litmus paper to chlorine gas? The litmus paper is bleached or changes color to white. Remember, litmus papers are generally used to test acids or alkalis, but you can also use it to test halogen gases. Another stage in the production of potable water is filtering. Explain why potable water contains dissolved solids after filtering. Now, filtering generally removes undissolved solids. So, for example, when you have salt water with sand, when you filter it, the sand is not going dissolved. So you can filter out the sand because that's a solid. The dissolved salts will pass through the filter paper because once they are in the liquid, when they're mixed or dissolved, they're far too small for it to be stopped by the filter paper. So answer for 2 marks. The dissolved solids pass through the filter paper because the dissolved solid particles are very small. You can say because They are very small. That's the end of question number 4, and I will see you in question number 5.